This is the first machine learning one I wrote, which gives you the general important point. This is TensorFlow is a Python library. There's two things that make this incredibly easy. The first thing is TensorFlow, a Python library that does the AI for you, where you only need a few statements to do it. And the second one is Google Colab. Google Colab is amazing. You do not need to install Python locally or any libraries or anything. You can just use this Google Colab free platform. And so you go here, you click New Notebook, and now it gives you a place where you can put in code and run it. And so you can you need this thing called TensorFlow, so you can just execute this stuff to import TensorFlow and see what version of it you've got. You run it, and there it goes. Executing 5 seconds, 7 seconds. It prints things down here as it executes. Okay, it's done. I have version 2.12.0, which is fine. I think any version would do. All right, so we can now run any kind of code we put in there. So let's give it a very simple problem to get started. Here's some numbers. If I have x going up by 1, -1 up to 4, and then I give you y values of -3, -1, 1, 3, 5, 7, and you say there's some relationship between those. Humans can figure out the relationship. You look at this and you realize the x is going up by 1s, but y is going up by 2s. So it looks like y is moving like twice x, but when x is 0, y is -1, so the equation is y is 2x minus 1. Now this is what scientists do, this is what learning is. You have some pattern of events, and then you have some events, and then you figure out the pattern that would explain them. This is, a scientist would measure things like the pressure of a gas as the temperature changes or something and graph it and then figure out what curve fits it, and that's how all science goes. So the question is, can a machine, you could program a normal program with this equation in there, and that would be fine, and that's the old-fashioned programming where you have to give it a series of steps that just tell it what to do, and it has no ability to learn. It just does what it's told, and it has no, we're going to have an AI that learns how to do this. And here's all the code it takes to do that. So you import some libraries, and then you make a model. This is a single neuron AI, a neural net with only one neuron and only one input. And here's the input data it's going to learn from, the same data where you have these x's and y values. And then it's just going to fit this model, try to predict it. And it's going to do 500 cycles of trying to improve the accuracy of its fit. And then it's going to try to predict the value for 10. Now the pattern is y is 2x plus 1, so the right answer for 10 is 19. And we'll see how accurate it is. So this is the code that does it. And you just put that code in here. And by the way, you could make a new box. Here, another code box. When I did this before, I just kept using the same code box over and over, but this is probably a better practice. You can, so I'll run this one. And there it goes. And here it prints out the loss. The loss is the measure of how wrong it is, how much error there is in trying to fit this model. And you see the loss is going down. So it's done 500 cycles of learning. And if you go back and look at the early ones, at the beginning, it was really bad. The loss was 0.7, but every time it learned, it got a little better, 0.72, 0.68, 0.65, so it improves. It knows, it does gradient descent. It figures out what direction is making the loss smaller, and it moves in that direction in parameter space. And so it got the loss down to something really small, like 10 to the minus 5. So it should be a pretty good fit, and as you see, it predicts for 10, 18.98, when the right answer is 19. So it manages to solve this very simple problem pretty well, which is not too surprising, but the point is I didn't program this relationship. It learned that relationship from the data. So here's what this looks like. If you draw a simple diagram out, you have x coming in, and you're going to fit it with a linear neuron that will just take a multiple of x plus a constant, so you have m and c, just two parameters. This is the linear equation of the neuron, and it finds those parameters, which are 2 and minus 1. It found them pretty closely, and so you can see what it learned. All you really need to do is this stuff. This is the last one. Here's what I learned. When I wrote this, I didn't know you didn't have to repeat the other ones, but Now I know you can just add another code block down here and see what it learned. And, oh yes, I'm sorry, I made this mistake before. I didn't save it in the variable L0. So you have to save it in a variable if you're going to refer to it later, so I will run it again. Don't actually need to import the libraries again, but I have to do this part from L0 and so on again. So I'll replace this with that and run it. All right, and there it goes doing the 500 epochs of training again. Which go by pretty fast. This Google Colab is apparently giving you access to GPU calculation. And so here's the 18.97, and here's the parameters, 1.996 and minus 0.989. So this should be 2, and that should be minus 1. And as you can see, it's very good, within about 1% in both cases. So it's able to solve that simple linear learning very easily. And so now let's try learning something that has errors. I just took some random errors and added them to these numbers. So let's see how much that messes it up. So I'm going to take this, and I'm going to replace the y with that. So I'll get here. I'm going to comment out this one. This is Python, so you can just comment out a line with a pound. There's the replacement y's, which are just the same numbers plus a little bit of noise, and run this one and see what happens. As you see, the loss is 0.1, 0.09, 0.05, 0.02, 0.004, and it never gets any better than 0.004. It never gets down to 10 to the minus 5 because it's putting a line through those curves and it can't really fit them exactly anymore. But it did. 18.95, it got pretty close to the right line, predicting that this number would be 19, and it found the numbers of 1.995 and minus 1.00, so it's pretty close to 2 and minus 1. So a little bit of noise did not stop it from learning and putting the best line through those curves. All right, and now I tried fitting a parabola. This is y is x squared minus 4x plus 5. Now that's still a simple formula, but that neuron doesn't have any ability to do a square. So all it can do is put a straight line through it. So here I calculated these values, and here's the y values for that parabola. So if you give it that data, all right, so let's get rid of this one and put in another one and run this one. And let it go. So the loss is really big, like 5. Before it was started at 0.4 and got down to 0.00 something. Here it started at 5, and it only got down to about 4, and that's as good as it got. And the end result is it's predicted like minus 12 here. It's very far off. It's trying to put a straight line through a curve, and it's not succeeding very well at all, which is not too surprising. And you can see it if you use this program, which actually plots the curve. This is going to take a nice curve. It's going to take x times cosine of x, which is going to be a nice curvy thing that goes up and down a bit. And then it's going to add random noise to it, 0.1 times random noise. So it's going to be noisy data that follows a curve, and it's going to plot the result. And so let's go to here. I guess I'll just add another code block and put it here. All right, and so now let this one go. All right, here, in order to fit this complex curve, I'm using a more complicated model, and I thought I had a diagram of the model, but I don't. We'll have ones coming up later. But what this model does, I have a diagram of the model here. Okay, this model does not use just one neuron. These neurons are still linear, but it doesn't use just one neuron. It uses one input neuron, which is the input x. Then it uses 64 neurons that can independently calculate something from x. Then it uses another layer of 64 neurons after that, and then one more. And this is how a human brain works. You have an eye, you have cells in the eye, you have neurons behind it, you have layer after layer of neurons, and they're originally just sort of randomly connected to other neurons, and they learn from experience how to more efficiently pick up things that matter to you, like objects and edges and such. And so this is got 2 layers of 64 neurons, so this has 4,000 parameters. Remember, the first thing I showed you was how many parameters it took to do various kinds of calculations. If you go up here, it was 0.1 billion parameters and 1 billion and up to 100 billion and 1,000 billion parameters to do things like ChatGPT. So this is much weaker than that, but that's what it is. Now we're up to 4,000 parameters. So there it goes learning. And here's the results. There's the curve. The dots are the input data, 1,000 dots, and the red is the curve, and you see it fit it very well. And so that's the real machine learning with 2 layers of neurons, so it's complicated enough to solve a difficult problem like that. And I just got some flags you find by using fewer layers, you varying different amounts, different layers, different numbers of layers and different neurons in each layer to see what works best, and changing the amount of noise and changing the amount of data points. There's quite a few variations to play here to see how it goes. So that's all I wanted to show you about that one. Let me stop recording this one.